Welcome to today's notes over simplifying algebraic expressions. In order to simplify algebraic expressions, today we're going to be combining like terms and using the distributive property. So let's go over what I mean when I say combine like terms. You also might see CLT, combine like terms. So first off, terms are the parts of an expression that are added or subtracted. I like to say terms are separated by plus or minus signs. Like terms are terms that contain the same variables raised to the same powers. So let's identify the terms that are alike in the expression below. I have 3x minus 4 plus 5x minus 2x squared plus x plus 5 minus x squared. So if I want to identify terms that are alike, I like to say they have the same last name. So they're the terms that contain the same variables raised to the exact same powers. So let's look at 3x. I'm going to circle 3x. And then I'm going to circle every term that is like 3x. Remember, terms are separated by plus or minus signs. So that's a term, that's a term, that's a term, that's a term. How many terms do I have in this expression? 1, 2, 3, 4, 5, 6, 7 terms. So let's find the terms that are alike with 3x, or that are like 3x. So same last name, x is the last name. Positive 5x, positive, if nothing is in front of that x, what can I put there? I can always put a 1, okay? So I like to say, sir, whenever you're combining like terms, which is what we're about to do, I want the sign in front goes with the number. Okay, so this right here is a positive 5x. This is a positive 1x. So those are terms that are alike. Well, let's look at other terms. I'm going to change colors here. I've also used highlighters. And I'm going to box this term right here, negative 2x squared. What's a term that's like negative 2x squared? Well, it's a term that's going to have x squared on it, such as this one. Negative, what can I put when nothing is there? 1, negative 1x squared. You don't have to put that 1 in front, but I think in Algebra 1, it's a really good, helpful strategy. So now let's look at the last ones that we're left with, the ones with no last name. Okay, right here, I'm going to use a different shape, different color, negative 4 and positive 5. These terms are alike. They're also called constants. They don't have any variable attached to them. They're constants. Minus 4. If I'm not multiplying it by anything or dividing it by, it's a constant. I'm always subtracting 4. This plus 5, it's a constant. I'm always adding 5 every time. So we call those constants when there's no variable attached to it. So to combine like terms, the first thing we need to do is identify like terms, just like we just did. Then you'll combine them using your integer rules. So what I really like to do is make sure you remember to rewrite with one sign in front. Okay, so let's get started on these examples right here. Number 1, so the first thing I want to do is identify the like terms. So 4x, what are the like terms that are alike with 4x? 4x, negative 5x, and negative 1x. So if I combine them, I'm going to use my integer rules. And if you're struggling with your integer rules, I'm going to put a little card in the upper right corner, and that'll take you to one of my YouTube videos over the integer rules. So 4 and negative 5x, different signs, subtract, take the sign of the larger number, then you'll be exact. So that's negative 1x, and negative 1x would make negative 2x. So I'm combining, and I'm going to rewrite it over here. 4 minus 5 minus 1. 4 minus 5 is negative 1. Negative 1 minus 1, same signs, add and keep. So I'm going to add them, and I keep the sign. I get negative 2. When we combine like terms, I like to say last name stays the same. So if I'm combining all of these terms that have an x on the end, when I combine them, my answer is only going to have an x on the end. So now let's do the other one. are constants. I have a positive 3, and I'm going to underline it twice, and a positive 2. If I combine 3 plus 2, what do I get? I get 5. Let's move on to number 2. So the first thing I like to do is rewrite all of my terms with one sign in front of each number, or term. So this plus a negative, just like we did with our integer rules, and I'm actually going to erase that. Plus a negative, I'm going to rewrite it as minus 3y. Plus 2x, if you see minus a negative, what can you change that to? One big plus sign. Plus 2x minus 6y. And now let's combine like terms. So the first thing we need to do is identify our like terms. So 5x, what are the terms that are like 5x? 2x, what else? 2x. So we combine them using our integer rules. 5 plus 2 is 7, plus 2 is 9. So 9, then last name stays the same, 9x. Let's look at our next term. Negative 3y and negative 6y. Those are terms that are alike. So when I combine them, I've got negative 3 minus 6, or negative 3 and negative 6, which when we did our integer rules, what did we do here? Same signs, add and keep. That would be negative 9. When we're combining like terms, last name stays the same, minus 9y. Let's go to example 3. In example 3, I'm going to rewrite it with one sign in front of every term. So 4x squared plus 2x minus a negative, I'm going to combine that and make it plus x squared minus 3x squared plus x. And then the other thing I'm going to do is if I don't have any number in front of a variable, I'm going to put a 1 there. It's like an invisible 1. It's like multiplying by 1. I still get x squared times 1 is just x squared, but it really helps students whenever you're combining like terms. So now, first, I'm going to circle my first term here, which is 4x squared. All the terms that are like 4x squared will have x squared as their last name, okay, quote unquote. Remember, same variables raised to the same powers. So the terms that are like 4x squared are going to be 1x squared and negative 3x squared. Even though these other terms contain an x in them, they don't have an x squared, so it's not the same. I can't combine them. So now I use my integer rules. 4 plus 1 is 5. 5 minus 3 is 2. Last name stays the same, x squared. And now let's combine our other terms. 2x and 1x combines to make positive 3x. So that positive or negative, when you write it down, I like to say it becomes your operation. So positive 3x plus 3x. So 2x squared plus 3x. Let's move on to the distributive property. So the distributive property states that when I have a sum or a difference in parentheses and I've got a number or a term right up next to it, I can multiply. This always confuses students. It helps to just show examples, but I want to have this written. You can multiply a number by a sum, or you can multiply a number by each term in the sum. Meaning, when I have this right here, 4 times 3 plus 8, let's look at the numbers first. 8 plus 3 is 11. 4 times 11, well, that's 44. Well, what if I take this 4 and I multiply it by each term in the sum? That means 4 times 3, which is 12, plus 4 times 8, which is 32. 12 plus 32 is 44. I get the same thing. So when we look at algebraic expressions, I can do the same thing. I can multiply a times b and then add it to a times c. A times b plus a times c. That's the distributive property. So let's look at some examples of using the distributive property. Let's look at number 4. So when I have a term or a number butted up right next to the parentheses, whenever I'm simplifying an expression, an algebraic expression, using the distributive property will remove those parentheses. So what I'm going to do is I'm going to multiply 7 times 3x, but I can't forget to multiply 7 times 4 as well. So 7 times 3x, well 7 times 3, we're going to use our integer rules. 7 times 3 is 21, and then I'm going to have an x there. Then 7 times positive 4 is positive 28. So that's how we simplify that. Now, one thing I want to point out, how many terms did I have in this set of parentheses right here? I had 2 terms. Whenever you're using the distributive property, you will still have 2 terms in your answer. So you need to make sure that you have 2 terms. And when you distribute something, both of those terms need to change. If you get something like this, 21x plus 4, what did you forget to do? You forgot to multiply 7 times 4. Everything gets multiplied by 7, not just the first term, every term. A lot of students forget this. Let's move on to number 5. Negative 2 times negative 4n, negative 2 times negative 1. What's negative 2 times negative 4? Positive 8. Don't forget your variable. Then negative 2 times negative 1. Positive 2. Again, I had 2 terms in my parentheses. I've got 2 terms in my answer, and they're both changed. Awesome. Good job. Let's move on to number 6. So notice I have a negative sign in front of my parentheses, but I don't have a number there. Just like with our variable, if you don't have a number there, you can always put a 1. How many terms do I have inside my parentheses? 1, 2, 3. That means this negative 1, in order to remove those parentheses, I need to multiply it by 1, 2, 3 terms. So let's do that. Negative 1 times 5y is negative 5y. Negative 1 times 2x is negative 2x. Negative 1 times negative 1 is positive 1. How many terms do I have in my answer? 3. Boom. I'm done. Let's move on to number 7. So again, I like to rewrite everything with 1 sign in front of the number. That really, it just helps with our rules, with our integer rules. So I'm going to rewrite this as 6 times 2a, and then if I see minus a negative, I'm going to change it to a positive. So 6 times 2a plus 1. And now to get rid of the parentheses, I'm going to multiply 6 times 2a and 6 times 1. What's 6 times 2a? 12a. What's 6 times 1? Positive 6. I've got 2 terms in my answer. They're both changed. We're good. Number 8. We've got a fraction. It's not a big deal though, okay? Again, it's a number that's butted up right next to my parentheses. In order to remove the parentheses, I need to distribute it into each term inside the parentheses. I've got 2 terms. 2/3 times 6x. So 2/3 times 6 over 1. If I'm multiplying fractions, it ain't no problem. It's the top times the top and the bottom times the bottom. But remember, I can pre-simplify or cross-simplify. I notice 3 and 6 both have a common factor, and it's 3. So I'm going to divide them both by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And now I'm going to go ahead and multiply across. 2 times 2 is 4. 1 times 1 is 1. So I get 4 over 1. So I'm going to rewrite that. I'm going to change colors here. 4 over 1, well, that's just 4. So 4, don't forget the variable, plus 2/3 times 12. Some of you might remember multiplying 12 times 2/3, where it looks like that. And you say, hey, wait, 12 divided by 3 is 4. 4 times 2 is 8. This is just 8. If you don't understand what I just did, you can always do 2/3 times 12 over 1, and then simplify it. 1 and 4. Okay, let's move on. So 4x plus 8. The next one, I've got a decimal. 0.5 is just what? 1/2. When I multiply something by 1/2, what am I really doing? I'm just dividing it by 2. So I've got 2 terms inside my parentheses. I'm going to multiply this negative, and I'm just going to say 1/2. Negative 1/2 times positive 4 is going to be negative 2. Don't forget your variable. Negative 1/2 times positive 2 is negative 1. Don't forget your variable. You can also write it like this, negative 2b minus a. In fact, if you're ever given a multiple choice test, this will be your answer. You won't have a 1 in front of the variable, but it means the same thing. So now when we put it all together, what if I'm given this long expression that has parentheses and a whole lot of terms in it? Well, the first thing you're going to do is use the distributive property to remove the parentheses. That's this right here. The distributive property, that's where we're multiplying in. Then we'll combine like terms in that order. So if you see parentheses in your expression, you got to remove them first. How do we do that? We distribute. So in this first set right here, I've got 2 sets of parentheses. I'm going to be distributing a 3 into the first set of parentheses and a negative 4 into the second set. Remember, sign in front goes with the term. So 3 times 4x is 12x. 3 times 2 is positive 6. Negative 4 times 5 is negative 20x. Negative 4 times negative 1 is positive 4. And now we've removed our parentheses, so now we can combine like terms. How do I do that? Well, I need to identify like terms. 12x is a like term with negative 20x. When I combine them, I'm going to use my addition and subtraction integer rules. So 12 and negative 20, different sign subtract, take the sign of the larger number. 20 minus 12 is 8. The larger number is negative, so negative 8. Last name stays the same. Then 6 is a like term with 4. What's 6 plus 4? It's 10, and that's my answer. Let's move on to number 11. In number 11, I've got 2 sets of parentheses here. So I'm going to distribute a 1/2 into every term in this set of parentheses and a 6 into every term in this set of parentheses. So let's do the first set. 1/2 times, remember that's just half of a number. I'm just going to divide it by 2. So half of 8y is 4y. 1/2 times 14 is positive 7. Let's do our next set of parentheses. 6 times negative 7y. 6 times negative 7 is negative 42. Don't forget the y. 6 times 3 is positive 18. So when we distribute, we're using our multiplying and dividing integer rules. Okay, we're using our multiplying. So let's do the next part. Now we're going to combine like terms. This is where we use our adding and subtracting integer rules. So what's the term that's alike with 4y? It's negative 42y. They're different signs, so we're going to subtract them. 42 minus 4 is 38. Is it going to be positive or negative? It's going to be negative because this 42 right here is negative. Take the sign of the larger number, and then don't forget, last name stays the same. 7 plus 18. When I combine those, I get positive 25. Let's move on to number 12. This seems like we've got a lot going on. So again, I have 2 sets of parentheses here. When I don't have anything in front, I can put a 1 there. What if I don't have anything in front of a variable? Can I also put a 1 there? Sure. So now to remove these parentheses, I'm going to distribute a negative 1 into each term in this set of parentheses using my multiplying and dividing integer rules. Then a negative 3 into this set of parentheses. So let's do that. Negative 1 times negative 1h is positive 1h. Negative 1 times 4p is negative 4p. So when I multiply that negative 1 into every term, what happened? The sign in front of each term just changed. That's it. So now let's multiply a negative 3 into each term in the second set. Negative 9h. Negative 3 times negative 7 is positive 21. And then don't forget this plus 2p minus 1. So we've got some different terms here. So let's combine all the terms that are alike with 1h. Negative 9h, and that's it. So I'm going to combine a positive 1h, which you don't need to write that there. It's assumed positive if there's no sign in front. So 1h and negative 9, those combine to make what? Negative 8h. Now let's look at our next variable term. Negative 4p and positive 2p. Those are terms that are alike. When I combine them, negative 4 and positive 2, I get negative 2. Last name stays the same. Notice I'm actually writing in alpha order. That'll come later on in your year in algebra, but H comes before P in the alphabet, so that's why I'm writing it in that order. And now look at 21 and negative 1. And notice I put a different number of lines underneath those terms. Whatever you need to do, you can use highlighters, whatever, whenever you're identifying like terms. So 21 and negative 1, those combine to make positive 20. Let's move on to number 13. Okay, I've got some fractions in this one, but that's okay because we know how to multiply fractions. So I'm going to multiply 3/4 into every single term in this set of parentheses and 2/3 into every term in this set of parentheses. If you don't see a number in front of a variable, what can you write there? A 1. And now let's do our multiplying. So the first thing I'm going to do is multiply 3/4 times 8/9, and I'm going to pre-simplify. So 4 and 8, the common factor is 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Okay, you can also look at it like this. 3 and 9 have a common factor, it's 3. 3 goes into 3 one time, goes into 9 3 times. Okay, and now I can just multiply across. 1 times 2 is 2. 1 times 3 is 3. So when I multiply 3/4 times 8/9x, I get 2/3 x. And now 3/4 times 16y. If you want to pause the video and do that now, you can. But I'm going to tell you what it is. It's 12y. That is 3/4 of 16. 1/4 of 16 is 4. So 3/4 of 16 is 12. 4, 8, 12. Then 3/4 times negative 1 is negative 3/4. In our next set, 2/3 times negative 1x is negative 2/3 x. 2/3 times positive 3y, is positive 2y. So now we've removed our parentheses. Now we can combine like terms. So the first thing I notice is 2/3 x and negative 2/3 x. Well, if I'm combining a positive and a negative of the same amount, they actually just cancel each other out, right? Think about 4 and negative 4. 4 minus 4, what do I get? I get 0. That's why I'm just crossing those out, because 2/3 x minus 2/3 x is 0. So I'm just going to remove them. Now let's look at our variable term. 12y plus 2y is what? 14y. And then negative 3/4 is all on its own. So minus 3/4. Let's move on to our last two examples, which involve geometric applications. The directions say to find the simplified expression that represents the perimeter of each figure. So the perimeter, what do I do when I find the perimeter of a figure? I'm going to add up all the sides. So I'm going to add this side, which is 6x minus 7, to this side, which is 3x plus 5, to this side, which is 4x. So I'm going to add up all the sides. So I'm just going to write an expression that represents this. And then I'm going to simplify it. How do I simplify it? I combine like terms. 6x plus 3x is 9x, plus 4x is 13x. Now I'm going to combine negative 7 and positive 5 to make negative 2. Let's move on to number 15. You can do the same thing this shape is a rectangle, which means this side is also 9y plus 12. And this side over here is 7y minus 1. But you don't need to write that down. You know that because it is a rectangle, which has parallel and congruent, opposite parallel and congruent sides. That's what these little tick marks are for. So that's saying that's the exact same length as that. So if I have two sides that are the same length, remember, P minus 2L plus 2W. You might remember that formula. 2 times the length plus 2 times the width is the formula for the perimeter of a rectangle. Well, twice the length is going to be 2 times 9y plus 12 plus 2 times the width. Well, that's 7y minus 1. And now I've got an expression that represents the perimeter of this rectangle. So now I need to simplify it. How do I do that? I'm going to get rid of my parentheses by distributing that 2 there and that 2 there. 2 times 9y is 18y. 2 times 12 is 24. 2 times 7y is 14y. 2 times negative 1 is negative 2. And now I'm going to combine like terms. So 18y plus 14y is 32y. And then 24 and negative 2 combine to make 22. And that concludes your notes over simplifying algebraic expressions. I know it was long, but it's good. So I hope it was helpful. And that's the end of it.